Okay, here's an example on applying Kirchoff's rules. This is the example that is out of the text that I have linked to. So I just wanted to review where we get all of our numbers from and where we get everything. This is all of our given information. I put in the direction of the arrows here. They always go from positive to negative. So positive is going in this direction, and then negative ends here. Same thing over here, positive in this direction, negative ending there. So this one is going clockwise, this one is counterclockwise. So we need to figure out the loop 1 and loop 2, and then we need to figure out the junction. And those, we have to create 3 equations, and we will actually solve a systems of 3 equations for 3 variables. So, this item right here, V1, in order to do that, we're going to go V1, it goes through R1 and R2, and we're going to subtract those because we have to get right back to V1. So, I know that might have sounded like a weird explanation. So V1 minus, to get the units the same, because we need volts, we will do I1 minus I1 times R1. And then we would also, on the path to go back around, it also passes through R2. So, and once it gets back around, it's going to equal 0. So that's one loop. The other loop, same thing. This would be V2 minus I1 R1. This time it's going to pass through R3. So minus I3 R3 equals 0. And then the third equation we have is the junction rule, Kirchoff's junction rule. I1 is equal to I2 plus I3, because I1, which is coming through here, is splitting and going in both directions, to 2 and 3. So 2 and 3 must equal 1. Anyhow, once we plug in numbers here and we rearrange these equations a bit, we would be able to solve this. This is where we're at. Let's put in our numbers here. This is going to be 12 volts minus 4 ohms minus 6 ohms equals 0. This one would be 8 volts minus I1 times 4 ohms minus I3 times 4 ohms equals 0. And then this one is still just I1 equals I2 plus I3. Now for ease, I'm going to drop these units and just solve for these variables, I1, I2, I3. I don't want them to confuse you. So this is going to look a little bit more like algebra. Now I'm also going to bump these over to the other side and just do some rearranging here. So this equation 1 is going to become 4 times I1 plus 6 times I2 equals 12. I moved these to the other side and they became positive, and I dropped the units. The next one is 4 times I1 plus 4 times I3 equals 8. And the third equation, I1 equals I2 plus I3. Now this is a system of equations. You would normally solve this, you normally have 2 variables, 2 equations. We have 3 variables and 3 equations. So to make this a little bit easier, let's get it to be 2 variables and 2 equations. This quantity, I2 plus I3 is equal to I1, I'm going to substitute in to the top 2 equations, and that will reduce them down to just 2 variables. So 4 plus 6 I2 equals 12. You see I just replaced I1 is equal to I2 plus I3. So I replaced I1 with I2 plus I3. This will be 4 plus 4 equals 8. Anyhow, I'm going to distribute and combine like terms. Let me rewrite these two equations. So this plugged in here and here. Anyhow, 4 times I2 is 4I2 plus 4I3 plus 6I2. So that's going to be 10I2 plus 4I3 equals 12. Here, 4I2, 4I3, 4I3. So 4I2, 4I3 and 4I3 makes 8I3 equals 8. Now in order to do this, I'm going to use the elimination process. I need to get the same variable and the same coefficient. I'm going to double this top equation, giving me 8I3, and then subtract the two equations. So, times 2, 20I2 plus 8I3 equals 24, and 4I2 plus 8I3 equals 8. Subtract the two equations. Anyhow, that gives me 16I2 equals 24 minus 8 is 16. Therefore, I2 is equal to 1. Now, at that point, we would just take this 1 and we're going to keep plugging it back into the other equations until we figure out what the other values are. Let's see here. Let's pull up another equation. I have this one. 4I2 plus 8I3 equals 8. If I2 is 1, 4 times 1, this is 4, plus 8I3 equals 8. Subtract the 4, 8I3 equals 4. I3 equals 4 divided by 8, or 1/2, or 0.5. Running out of room a little bit here. And now, the last equation I'm going to plug back into is I1 is equal to I2 plus I3, which is 1 plus 0.5, or 1.5. Sorry, ran off the page a little bit. Now that I have those values, I want to put those units back on. It's just easier to do the algebra if I don't have all those units. It gets a little complicated otherwise. So, we are looking for the current. So I1 is equal to 1.5, and that's amps. I2 is 1 amp. I3 is 0.5 amps. Now we want to know what direction each one is going in. This is 1. 1 is going downward because it's not going counterclockwise or clockwise at this point, because it's just going, they're both going in, they're both coming down, and they're both separating. So this one is downward. R2, we could recognize this as clockwise. And I3, because it's going right here, would be going counterclockwise. Okay, hopefully that helped all of you, because this one was a little bit tricky. Let me know if you need any more help.